In this video, I'm going to walk you through how to write my code for Homework 3. Starting with part 1. I first imported all the necessary libraries here, which will later on to be used to run my code. And then I divided the dataset into two sub-datasets based on the year in the text file name. If the year is less or equal than 1913, then that will be the pre-World War I dataset. And the rest of them will be the post-World War dataset, which will contain the years greater or equal than 1917. And the code is here. I also do a quick check of the number of the words in each dataset. And then I normalize the text for each dataset by downcasting all the words. Move on to Unigram. I clean out the dataset as just a list of words for each dataset. So I have the pre-World War I and the post-World War I. And then with those two datasets, I apply the frequency distribution function on it and get the frequency of the words or frequency of the unigrams for each dataset and get the 200 most frequent unigrams of the dataset for each one. Here is the quick view. And then I filtered out for the unigrams that are in the stop words or has a less than 2 because I do not want those words in my dataset. So here's the code and here's the quick view of the output. And then here are the code to write out to the output text file. And I create a list of combining the words from pre-World War I and the post-World War I. And here's the quick view. And then here's the code I run to print out the text file here. And here's the quick view of the output. Move on to bigrams. Similar process, except as the first process, I use the bigram function to get the bigram of each dataset. I use the frequency distribution function to get the bigrams frequency and get the 1000 most frequent bigrams for each dataset. Also filtered out the stop words and the words has less than 2. And here's the quick view of the filtered out dataset. Similar process, I create the list of bigrams from pre-World War I and post-World War I, and then I print out the output text file to here. The text file will be saved as the same location as the source code. Move on to the bar chart. Here are the library that will be used to create the bar chart. I create a dictionary which contains the probability for the bigram for the pre-World War I and post-World War I, and also store the differences between those two probabilities for each bigrams. Also sorted by the differences, and here are the code to print out the plot. And here is the quick view of the plot. Move on to the PMI. I firstly create a dictionary for to get the frequency for the ugrams and the bigrams for each dataset. And I imported the math library, which will be later used to create the PMI score. Here I call the functions, and here are the code I'm going to calculate the PMI score. And then here's the code I'm going to filter out and only include the bigrams, include the words economy. And here's the quick view of the top 45 bigrams contain economy and the higher based on the PMI score. Similar process for the post-World War I. And then here is the text print out for the PMI score. And here's the quick view. Then move on to the part 2. Also similar process. I import all the necessary libraries. Here's the code. I will combine all the list of words from the 3 text files that are required for this project. The text 2, text 5, text 6. Apply the bigram on the list of words and also apply the left placing smoothing on the dataset. And then I create the function random pick, which will later use in the generate model function here, just to select the next word probabilistics. And here is the generate model function, which is I modified the NLT case generate model function, adding the parameter of the methods of 0, 1, 2. So I run here. And here I'll just call the function and generally see the results. And in order for the reflection part, I want to see what tags are from what kind of text file, how we can identify. So I'm interested about, for example, edge, wood, and that will occur in text file 5, but not in 2 and 6.